So the thing that I wrote on the thumbnail of this video is not clickbait. Such type of questions do ultimately end up deciding the final rank of students. To understand why, think from the point of view of any examination. There are lakhs of students who are going to give an exam. Many of them will not qualify. Some of them will get the ranks of around 5,000, some in around 1,000, and so on. Gradually, as the rank reduces, that is, as you get ranks closer and closer to 200, 300, you have questions like these. These questions end up deciding what differentiates those ranks, because such questions will not be solved by the majority, by a vast majority. To truly understand why this question is of that level, just give it a try before watching the solution. Also take a note of how much time you take, because it's not only about solving the question, it is also about solving the question in a limited time frame, because you will also be solving other questions as well as physics and chemistry in the exam, right? So it's not like you can give this question like say 20 minutes or 30 minutes. You have to be very quick. That is why I said that such questions end up deciding your final rank. But even if you're not able to solve it, do not worry, because as I said, not every question needs to be solved in the exam. But now, because we are studying, we have all the time, so it's better that we increase our thinking capacity and increase our logical thinking skills. So when you decodify this question, as with most questions, it is not that tough. But the problem is to understand its language and the roundabout way of asking you when two lines have one solution, when they have infinite solutions, and when they have no solutions. How can you start thinking that this is about straight lines? You have exactly one element, infinitely many elements, and no elements. So you have, looking at the options, you can see that you have three possibilities, and such possibilities are only possible when you have two straight lines, and when you have either one solution or infinitely many solutions, that is, the two lines coincide, or no solutions, that is, the two lines are parallel. So you have to start thinking on those lines. Regardless, let us start doing it. Let str be non-zero complex numbers, and let L be the set of solutions of this equation. So because you have nothing given here, let us start by assuming S, T and R in forms of x plus iota y. Z is already given as this, so we will take some other constants. So let S be alpha 1 plus I beta 1 and so on. Now substitute all those assumed values in this equation. So you will get something like this. Now this is standard form, as in you take the terms together, you compare, you put all the real terms together, all the imaginary terms together, and equate them to zero, because you have zero on the RHS. This is how basic complex numbers proceeds. Like this is how you start this chapter when you solve the basic questions of complex numbers. So exactly like that. So you're equating real part and imaginary part, and when you do that, all the constants that we have assumed come together in a very definite form, or let's say in a very specific form. So you have equation of two straight lines, and they have emerged from this equation. So if L is the solution of this equation, and you have two straight lines emerging from this equation, so L will be the set of solutions of those two straight lines. What it means, that either they can intersect, they can be parallel, or they can be coincident. That is what I've written here. L is the solution of the equation. Since the above two equations, that is, these two equations, are based on this equation, L is basically the solution of the two linear equations written above, that is, these two equations. Let us see the first option. If L has exactly one element, what this means, that those two lines intersect, and two lines can only intersect at one point. Then we have this thing, mod of S and mod of T. Now the beautiful thing about this question is, once you equate the coefficients of the two straight lines that we obtained, as we have that condition in straight lines, right? If two straight lines are parallel, their coefficients, the ratio of their coefficients are equal. If they are coincident, they are equal, all three ratios are equal. And if they intersect, the ratio is not equal. Exactly same reasoning. So the ratio of these two, a1, a2, b1, b2, when it is not equal, then we will have intersection or only one solution. So the first option is basically that. So pretty simple. This upon this is not equal to this upon this. Ratio of coefficients. Simply take, cross multiply it. What you will get is alpha 1 square plus beta 1 square is not equal to alpha 2 square plus beta 2 square. And as I said beautifully, they will come out to be the modulus of these two complex numbers that we have assumed. because alpha 1 square plus beta 1 square is the modulus of s square. Similarly, alpha 2 square plus beta 2 square is the modulus of t whole squared. So what you will get is mod of s square is not equal to mod of t square. Therefore, mod of s is not equal to mod of t when these two lines intersect or when L has exactly one solution. So this option is correct. Then the next thing is, if mod s is equal to mod t, then L has infinitely many solutions. So when two straight lines have infinitely many solutions, the ratio of all the coefficients is equal, right? For that to be the case, alpha 3 upon beta 3 should also be that specific ratio. But because R here is any random complex number, we have no idea of what alpha 3 and beta 3 are. So we are not given any condition. So in general, if we have no condition, then we have to just focus on these two. So if mod s is equal to mod t, then we will get this ratio as equal, right? So instead of inequality, we will get equality. But because we do not know what the third ratio is, the most we can assume is they are parallel lines. For coincidental lines, there should have been a condition on alpha 3 and beta 3 or a condition on R, but it is not given. So at most we can say that they are parallel lines and they have no solution. So this is wrong, because at most what we can say is they are parallel lines, so they will have no solution. For L to have infinitely many elements, there should have been a condition on R as well, so that we could have said that okay, because these are this ratio is the same, they are coincidental lines, but that is not the case. Third option. Now this is, as you know, the equation of a particular circle. But again, the beauty of this question is this could have been any equation of any random circle. It could have been mod of z is equal to 551, let's say. Even then the same logic would have applied there. They have taken it to be a circle, but this need not be a specific circle. Why? The number of elements in L intersection this circle is at most 2. So this is another question or another option that requires absolutely mind-blowing thinking. What this requires is, first assume, draw a circle. Okay, so we have a circle. Then what is L intersection those circles? L is basically those pair of lines. So how can you draw them? There can be only two options here, because if you draw parallel lines, so there is no intersection of L and this circle, right? Intersection means there should be common points. We are not talking about just two lines having different intersections. Then the at most intersection could have been four. But we are not talking about that. We are talking about the pair of intersection of this pair of line and circle. So either they can intersect at exactly one point when the point of intersection of those two lines lie on the circle, or they can intersect at 2 points when we have coincidental lines, or L represent coincidental lines. So the number of elements is at most 2. It can be either 1 or it can be either 2. The third possibility is not even possible. So this is correct. And finally we have, if L has more than one element, then L has infinitely many elements. Simple logic. If two parallel lines have more than one solution, it means they are coincidental lines, so they will have infinitely many solutions. So this is also correct. So yeah, JEE does ask questions like this every year because it has to differentiate the final ranks, right, of students who are at the very top. But for a normal student, let's say you're a normal student and you are giving an exam, and you have stumbled on a question like this, which you will in every paper. So the first thing would be to skip it. If you're not able to solve it, skip it, because deciding rank only matters when you will get a rank, right? First you have to qualify. First you have to be of that caliber that you have a rank of around 1500, which is a big ask. So if you are an average student and you feel that even qualifying for an IIT is a big task, then it is advisable that you skip such questions. However, if you are so, but since you are a student, then you have to solve every previous year question. That's non-negotiable, because then that is how you will update your thinking, and that is how you will expand your thinking capabilities, and that is how the chances will increase that your rank will improve. So this channel is about all that. We teach you theory as well, but we also teach theory keeping in mind how to apply those in exam situations, under exam conditions, keeping in mind that it is not only maths that you will be solving, you will also be solving physics and chemistry in a particular time frame under immense pressure, when you will forget formulas, when you will do calculation mistakes and so on. So if you like such type of content, please follow this channel and check out the other videos where we have analyzed previous years questions as well I've taken some difficult theory topics and explained them in an easy way with previous year questions to help you internalize those topics. Thank you.